Hello, viewers. Hello, and welcome to Tech Simplified TV, and a very warm welcome to the Semiconductor Podcast. We are back with another episode. And today, our guest is Dr. Prometheus Dasmahapatra, a young photonics expert. He has completed his doctoral and postdoctoral journey in Europe, and he has worked with two very famous, world famous companies, imec and ASML. Right now, he is serving as the CTO of imec Private Limited, based in Hyderabad, a young photonics expert in our podcast today. So we will try to understand his experience, obviously, because he has seen the research scenario and industry scenario in Europe, and it's more important to know. Many people may know I have not interacted with so many people with this kind of background and experience, and it has become more important when I have a little bit of knowledge that after India EU deal, the deal of mother of all deal kind of deal has happened in last 3 months. So after that, this kind of conversation has become more important. So please join me to welcome Prometheus. I think Prometheus is facing a little bit of net connection problem while we were joining. That time also, he has faced that. Okay, let's wait for him. He has said if he get any kind of issue with net, he will rejoin with his phone. So let's wait. It's a very unusual thing at the starting happening of such thing, but I will wait for him. I think he will join soon. Yeah. Yes. Prometheus is back. Hi. Yeah. We are very persistent engineers. We don't leave things so easily.
I mean, this was a wonderful start actually, because I think a part of the discussion you will talk about my journey with startups. And one law I particularly very much prefer and talk about is Murphy's Law, where everything which can go wrong does go wrong. So it's a preparation for startups. Let's call it that. That's how the call started off. Everything which can go wrong does go wrong, but we find a way to overcome it, right? That's, I guess, a part of the challenge in life.
We don't leave things half done. We we will make it possible.
Absolutely, absolutely.
That is the fun of having a live show, not recording. It's I think this is fourth of my in all of these episodes. This is the fourth one. Happened this kind of disconnection and all. In one of my episode, we had to break it in 2 weeks into the first one.
Right. So if anyone from Airtel is watching, this is not a great advertisement for you. So you can work on improving your internet. That's what I'm saying.
Let's make it viral.
Make it viral, right?
Solve this problem. Many people will get benefited with this. Okay.
Absolutely, absolutely. So it's a nice platform to bring it up, I guess.
Okay, so we will start with your journey. You are very young. Research. You have got research background. You are an entrepreneur. Right now, you are CTO of a company based in Hyderabad. So, what actually attracted you to photonics and semiconductor research, and how did your journey begin?
Well, before going there, Moon, thanks a lot for the introduction. Do appreciate that. An extra bit of appreciation for calling me young. I don't get to hear that quite often these days, so do appreciate that even more. And a bit of a warning to everyone: I have a very large German Shepherd in my room. Hopefully, she doesn't start throwing a tantrum, but we'll see how it goes.
Yeah.
Now, coming to what you asked about my career. I think growing up, right, when I was quite young, I was a big fan of an author called Michael Crichton, who's very much into sci-fi. I like reading about sci-fi, and that's where first, the next generation, so to speak, possibilities of semiconductor-related world was something that I came across more as a vision of an author rather than maybe realistic possibilities, but that drove a lot of the interest towards science from my end, right? In terms of semiconductor research, well, that's where it started off. That's where I went for my master's at University of Manchester. I was working primarily on material growth with Professor Mohammed Misous, a wonderful and brilliant professor in his own right. And a big influence in that time in my career was another lecturer that I had, Dr. Max Migliorato, at the university as well. Uh, it's funny when I think about it right now. I had actually had a bit of aversion to photonics, and I always used to think in my head that okay, maybe that's not the career path in terms of research that I would follow. But for some reason or the other, and I think Max will know better the answer to it, he took a bit of a liking and vested interest in me. He really acted as a mentor in terms of showing me the how to carry out self-learning, how to get interested in the field itself. You doing something when you love it provides a different drive as compared to when you're compelled to do it, right? And his interest was in certain ways a validation as well. Someone who is at the top of his field, taking a vested interest in me, uh, took a lot of time to even make me familiar with things such as what is scientific methodology and what is the process which needs to be followed behind it, right? To take it up and to do things, so to speak, the right way, right? And I think that played a huge role. I've been fortunate enough to work with some truly brilliant people. If you ask me, I don't know how it happened. I just say I'm very lucky, and I do believe that. Hopefully, that luck persists. And I think they had a huge role in shaping my career and showing me uh, different ways of doing things, and also having an understanding of what is correct methodology, and also always having an open mind, right? I think a big part of science and research is that you do not close yourself to options which might initially seem impossible, might seem too far-fetched, but a big part of what we do is try to achieve those. So that's, I would say, like what drove me into this.
Okay. So you have worked across industry, research labs, and startups. How did this environment shape your approach to innovation?
That's an interesting question. I've never really mentally done a comparison of them, so this will be me thinking out loud. I think the industrial approach was and is quite different from academic and research-oriented work. And I do mean that in a positive sense, right? A lot of, especially if you're working for a larger company, right? A big drive is the financials. There is no denying it, right? It's not a non-profit organization. It is an organization which has a particular purpose in terms of its development goals and so on. But even in that, I would say working with a lot of people, the structure that is there, the structure to achieve things, collaboration between different teams which are often very large, right? Teams which, if you compare to startups, might be the size of a startup itself, a team, right? And how to get these done by proper structuring, proper planning of execution. I think that's a big takeaway for me, at least, and I think for most people who have had the good fortune of entering into such environments. Uh, Research labs, well, if you're talking about government research labs, a little bit different from academic ones. I think, and again, I mean this in a very positive way. In academic centers, we primarily, if you're looking at core research, right, it's things which you find to be fun. I don't mean that to sound as if it's wasteful. It's not. But a lot of times when you are developing base and core concepts, right? It is largely an innate feeling that you get, an intuition that you have as well in terms of the development, and something you truly enjoy. And that's very much required as well, because an analogy I always use is that the reason why comparing or talking about a movie called Back to the Future, why we don't have flying cars right now, although they are about to come about, I guess, is because in 365 days, maybe 364 days as a researcher, right, we fail. Things are not working properly in the lab. Something is wrong. You are scratching your head, right? You're spending day and night to get it fixed. And maybe that one day of so-called success, however you define it, is what drives you. And that's a huge motivator. So that's something which is, I think, different in research labs. Academic would be in Europe, it's a little bit different because academic has some industrial involvement as well in terms of projects, how proposals, right? It can be a combination of different parties involved. Government research centers, I think, are more driven towards building an ecosystem, helping the ecosystem to build. So that would be primarily the kind of differences there are. And startups is dreaming big with a huge chance of failure, but a very small chance of success. But that chance of success is, I guess, one of the biggest drivers, at least for me personally, and I know for a lot of my colleagues in different startups environments as well. So I would say startups are actually more closer to research labs in that sense. But yeah, the industrial impact or working in an industrial environment is something we should always strive to do, because there's a reason that why they're at the top of their game. There's a reason why they are so successful in terms of their work ethic, the distribution planning, and everything. So I think there's a lot of things that I have personally learned and try to implement in my career so far from there as well. Moon, you're muted. Yeah.
Yes. You have worked in ASML, and I have a question regarding my third question is based on that. Um, first, first you tell me that what it feels like working in ASML. That's one thing. Another one is what kind of challenges you are solving in industrialization while you are working in ASML. Tell me what it feels like working in ASML.
So it was truly a great experience from the get-go itself. I always recommend ASML to people who are looking to work in a very industrial environment, right? In a very well-established, top-of-the-line company. One very big credit, I think, which is often undermined in certain instances in life, is that they treat their employees very well, and I think that's why I'm not sure of the exact numbers right now, but I think ASML has a very high employee retention rate as well, right? Because in terms of taking care of you, so to speak, as an employee, in terms of the work that you do, that making sure that you're not in a very you're in a positive work environment, the negativity around you is minimum, that you have enough breaks as well, so to speak, to produce the output that is demanded of it, uh, in every which possible way, right? I think it's a very good environment to work with, a very friendly environment as well, especially considering the huge size of the company. And in terms of the challenges of it, so I was fortunate enough, again, a big part of my good fortune, I guess, when extreme UV machines were just about to come out, right? So I got the good fortune of working with like uh, zeroth generation to maybe the second, third generation of these machines. And it was a wonder and a pleasure to do it. You know, it was also very eye-opening to realize that even in bigger entities and companies, when you're talking about a massive change in the technology or something really which shakes the technology world, that kind of a technology coming in, it's not as if from day one you get everything right, but even there's a process in which you gradually build, right? Have had the good fortune of going to a few customers as well who were just starting with the implementation of those equipments and having a look at their sites. The entire science and the idea behind these UAV machines, I think it's mind-boggling, and it's a testament to the entire company itself.
Actually,
And
that's
yeah, sorry,
asked you
please
that.
go.
Actually, that's why I asked you that question, because
Yeah,
that movie Machine, and Nitin came to. I was fortunate enough to have him in my show. Nitin Dahar,
right, right.
uh,
Yeah.
the editor in chief. I asked
Okay.
him what it feels. He was saying that we were invited. We are walking and walking and walking, and it's such a huge machine. You can't believe it. And he was the first person whom I asked in person who has seen that machine in his own eyes, and now you are the second person. Every time I wonder how people can make such big machine for a complicated steps, and we
Mm.
are actually human being, we are so persistent to achieve something as a collectively, individually, depends on every person. But every time whenever I think about that machine na, it gives me goosebump. Is it possible to make such a huge machine? How is it possible? I might be there are many other machines, but obviously it drew my attention because it's in my field, something related to VLSI, that's why. So
Right,
what
right.
kind
And
of
even I'll add one thing if you allow
industrialization
me. I mean,
you are doing solving
y-
there?
yeah, so we were looking at mainly the optics part of it, right? And that I think holds relevance to the latter part of, or related to a lot of my future work and some of my past as well, is just understanding again in such a large environment when you're working with optics, the nitty gritties of it, the nuances of it, and the dependencies of it as well, right? Like just getting a system of that sort, make sure that everything is aligned and working the way they should work, which I won't give away too much, but that is basically a persistent problem in photonics and integrated photonics in particular that we face as well. You get a feel for the massive scale and the importance of it. And without going into too much detail, because I shouldn't, how to tackle them as well, because that also becomes
No,
equally
no, no,
important.
nothing. No. Just generalize. No, no
Sure.
confidential. Obviously, we all are
Mm,
bound by NDAs. I know, I understand, because I have
mm,
also worked in companies, and with we are publishing these tutorial videos for last 5 6 years, and we
right.
always keep in mind that what NDA we have signed. So we understand
Absolutely.
that.
Mm.
Uh, Now, my next question that. You have worked in large semiconductor companies and research institute and small companies. So what is the key differences did you observe between large semiconductor companies and research institute? If you please compare these two.
Yeah, I think I was kind of trying to allude to this before. I think in terms of the business, of course, right, there are a lot of the obvious differences, right? Larger companies with a larger amount of business that you occupy in terms of the global domain itself, whereas research institutes, what you're looking to do primarily, and especially for government research institutes even more so, is you are primarily looking at helping and building the ecosystem surrounding it, right? So for some of the government institutes that I've worked for, a big part of the work has been, for example, to optimize and then start some pilot line programs in terms of fabrication, in terms of development, so that more than I would say larger companies, which have maybe the financial prowess to do with things, smaller entities such as startups or people just delving into new ideas, right, have a platform on which things they have things to build on. This is even more so true and important when you're working with hardware. I'm not only talking about semiconductors or photonics, but hardware in general, right? One of the things about hardware is it's very cost intensive, especially the research and development stage of it, because you require tooling, you require a lot of things which are custom when you're doing something which is totally new. And that increases your initial development cost a lot more because the NRE cost, so to speak, right? The non-recurring expenses are quite high in that sense. And almost unheard of in hardware development is a first-time approach where you get everything right. So that means second or third time when you need to do it, right, a lot of these costs need to be incurred again. So the entire process in itself becomes quite expensive. And that's why I think research institutions, especially government research institutions, primarily what I've worked for, I think play a very important role in giving an opportunity to people with dreams and uh, very impactful ideas to realize them and take them forward.
Okay. So now let's move to the subject you are working on, that is photonics. So, uh, in I would request you to explain photonics in its simple words for our audience,
Right,
and how it differs from traditional electronics. Actually, this is our second episode on photonics.
right,
Previously had an episode with Professor Vijay Krishna Das from
yeah,
CPIX, co of
right,
CPIX. That episode was very popular and and people admired that episode very much. So this is our second episode. If you please describe in simple words, because many of our viewers are students also.
right. No, that's good. Fortunately, I've had some experience in doing so, especially in discussions with VCs and so on. So hopefully that helps. I mean, in the most simplest terms, electronics or the basis and the crux of it is formed by transfer of electrons, right, from one point to the other. And in photonics, instead of electrons, we work with photons, right? And why photons? Well, so far as humankind is concerned, based on the knowledge that we have, photons are the fastest particle known to man, right? So that inherently, when I say this and when I tell you that we are using photons to send it from a point A to point B and hence perform some functionalities, electrons are relatively slower. So you can already speculate that there would be the advantage of speed and bandwidth coming in, right? That's the primary reason why we have looked into it. That's the primary reason in terms of true commercial adoption of photonics. You see it in data centers or even in, uh, for example, the internet that we have at home, right? You see an optical fiber coming in, that's what we connect to our modem. So that's an optical means of transmission that we are working with. How it differs? Well, in terms of the basic principle, I would say there are two ways it differs. One is it is bidirectional, inherently bidirectional. There are some orthogonalities because of which you can do things like wavelength division multiplexing, meaning over one channel, which we in photonics often term as a waveguide, right? Over one element through which you're sending your signal, you can actually send multiple wavelengths, which are spaced from each other. That is one or 1A and 1B. And the second one would be the sheer fact that inherently it is also analog. The analog nature, by the way, is something which also helps in processing or future requirements for processing. So that's why you will see there are a lot of AI hardware or accelerator making companies or startups and larger entities as well who are looking into photonics as a means for achieving hardware accelerators primarily for the domain of AI, right? So you can look at basically neural network kind of options, or even moving further, look into neuromorphic computing. But maybe I digress and maybe I'm going in too much into technical details. But there are advantages of this. A simple analogy in that sense would be if you're working in an analog domain, right? You think of the maths that we do, right? That maths that we do, that is inherently analog, right? We are thinking of all the different number combinations. If you're talking about any kind of AI-based approach, you're primarily doing some kind of a matrix manipulation, transformation, and so on, right, with analog numbers. So effectively, you can do that directly in analog means instead of having to move to a binary means and then finally converting from the binary to analog as well. It's, of course, not as simple as I'm describing it right now. There are challenges across it, but that's the crux and the main, let's say, interest in it. And then the third one, which I'll also add, is there are things such as like coherence coming into play, which affect a lot of communications. Also, for example, you can work with quantum states in particular, which has a lot of applications in quantum technologies. The fact that you can do this at room temperature, right? In particular, in the domain of quantum technologies, if you look at quantum computing, right, that's where a lot of interest in photonics come into play because you can do these kind of processing of quantum particles in or quantum means in that sense at room temperature instead of having to go to close to 0 Kelvin.
Okay, so the photonics, as much I understand that for photonics, silicon photonics, all different set of devices are required, not the existing one which we are using. So it requires it under research and work is going on. It's an upcoming, or it's already has arrived and rest of the part will arrive very soon, this kind of technology, and it requires a lot of investment in it because a new set of thing. Still, in spite of all of this thing, my next question is regarding that why, if we consider all of this thing, that why silicon photonics gaining so much momentum today in spite of all of
So there is, like with most things, there is no generic answer, so to speak. There's a lot of application domain-oriented things coming into play. But I'll maybe change the question a little bit as well, and not only talk about silicon photonics, but photonics in its entirety, because I think that's more of a fair discussion to have, right? Silicon, to start off with, just owing to its abundance, right? Abundance on the face of this earth, has a lot of interest. We have seen that being a big driver in CMOS industries, right? Even to a certain extent, if you compare with 3.5 based HEM structures, right? In several cases, their performance might be better, but silicon, just owing to the abundance, and that kind of relates to the cost of it and the amount in which you can produce it, has a lot of realistic implications which we need to keep in mind, right? As parallel to this, or maybe in a bit of an opposing direction, you can think of, for example, 3.5 materials which on the face of this earth are not that abundant. You can think of, in terms of electric vehicles, lithium, right? Lithium is becoming a very important resource, but we know that we don't have lithium as much as in abundance, right? So the sheer abundance of it in terms of commercials become very important. Now, in terms of photonics, broadly speaking, so far, at least in the short to moderate, maybe a little bit in the long-term future as well, you will still need a combination of silicon with group 3.5 materials, because you need a light source effectively, right? That's what group 3.5 gives you. Silicon doesn't, at least so far doesn't, but there is a point of investigation related to it. In terms of the applications themselves, right? If you're talking about mostly communication-oriented applications, it's again, the speed and bandwidth related item that I talked about earlier. So we know that the data demands right now are, if you think about it in a holistic way, maybe going crazy, but that's the nature of it. There's an exponential rise in it, and it doesn't look like it will slow down. So their technology of this sort, which has the potential of being higher speed, higher bandwidth, and then using technologies which I kind of alluded to, like wavelength division multiplexing, where over one channel you can say multiple wavelengths with each channel having its own set of information embedded into it, or each wavelength having its own set of information embedded in it, becomes quite critical. For quantum technologies, the ability, especially for quantum computing, the ability to do things and processing at room temperature becomes extremely important, right? Not only in terms of the cost, because these price systems are very expensive, very large, difficult to maintain, and so on, but even in the longer term adoption of it and the adaptation of it into more like a niche product, which is only meant for high-end users, to gradually, over time becoming a more readily available product. AI is another one where it takes a lot of, there's a lot of potential, again, from the bandwidth part, again, related to the speed of it, and also the latency associated with things, right? There's a very nice paper, and I don't want to go into too much detail on it, but there's a kind of a pathway shown whereby, in terms of in electronics, how the bandwidth scales as a function of the power consumption, right? It's shown over there that it scales as a power of 3, whereas in photonics you can achieve basically a scaling where the power consumption scales as a power of 1, right? So it's a lot. It can potentially at least be made a lot more efficient as well. So this even edge computing, if you're familiar with it, where basically the concept is, instead of having a whole set of data, being generated at where your sensors are, and then all of it being transferred to a data center somewhere else, and then processed. Maybe part of the processing can be done closer to where you're taking out the data, right, where your sensors are, so that you can reduce the amount of data which is being transferred, right? Over there as well, using means of this sort, using analog processing, for example, using photonics, has a lot of applications and has a lot of potential benefits. It's just that in a vast majority of these, we are looking at the problems which are at hand and trying to overcome them to show true commercial viability of these products, right? I think that's where, so the engineering front, I would say, is more where the problems are being looked at in terms of photonics. The science of it, a lot of it has been established, has been demonstrated. Now it's the work of primarily engineers in tandem with scientists to make it viable, to make it product ready, and to have it as tangible things which you can just buy and use, right?
Okay. And as you said that that to make the technology mainstream, so what are the biggest technical challenges in integrating photonics with CMOS technologies? I mean, with
Yeah.
existing technology, how can we integrate that?
Right. So again, I would refrain from a generic answer to it because application-wise, it changes a lot. So maybe I'll try to divide it into smaller sections to answer this, right? Uh, one one aspect of this, since you bring up CMOS, I disagree with a lot of my colleagues in this, is that CMOS in particular, a very small part of CMOS is what is SOI, which is silicon on insulator, which is primarily what we do in silicon photonics. So of course, it's still silicon and silicon, so some of the process steps are similar, but as the old adage goes, devil is in the details, right? So if it's not exactly the same, there's still like translatory work that you need to do to move from one to the other. I think in terms of the challenges or the adoption related issues, right? You, again, in the short to medium to relatively a decent aspect of the longer term view as well, right? You will still need indium phosphide. So the integration of indium phosphide or not only indium phosphide, depending on the wavelength, any 3,5 material with silicon, that remains a big challenge when we are working with things. Along with that, in terms of, for example, let's say quantum communication, right? And quantum computing and things of that sort, where the nitty-gritties and the electronics and the feedback associated with it the tolerances are very low, so to speak, right? You have to get things right in terms of the integration of it with a large yield and a large scale, right? I think that's where a lot of the work is going on currently. A lot of it is also promising. But the thing is, I see this as someone who's more on the technology front. When I possibly solve one of these issues and go to someone on a business front, they will ask me, instead of the yield and everything else, well, they care about that, but more importantly, they'll care about the cost as well, right? So having this in a cost-effective manner becomes very important. Again, in a field like quantum computing, you can kind of get away with the cost because initially, like with any new technology, right? Talk about our computers. When they started off with very large systems and so on, right? They were very expensive and people were kind of okay with it, right? It's just with gradual increase of their use, a decrease in the cost came about because what was this considered as your NRE, non-recurring expenses, right? You have the economy of scale, so it gets spread. You have more technology development in terms of processing, and that becomes more accessible to the common man, so to speak, right? So those things come into play, but I think initially it will be a kind of product which is more on the expensive end and for very niche markets coming in. And gradually with time, you have these scaling factors coming in, reducing the overall cost, right? Other than that, I mean, heating is an issue in photonic integrated circuits. Our lasers that we work with, they go through a process called self-heating. So they heat themselves up, which is not really great because when they heat themselves up, they change their own properties, their KPIs and their performance metrics, right? And of course, the heat doesn't only stay limited to the laser, it spreads out as well. And the other major issue is that the tolerance to variations in fabrications, which we often term as phase variations, right? It is quite low in photonics. So you have to take into account certain means to overcome them or design accordingly and be very clever so that you can meet like very large circuit demonstrators or products which actually do work rather than working in principle, they work in reality as well. So I would talk about primarily these things.
Okay. Okay. So understand. So do you think all these things, technology, cost, more production, everything, if we consider all of these things, so this kind of technology will be in very mainstream in coming 4-5 years, or more it will take?
It depends a little bit on what you mean by mainstream. I think initially, again, history has shown us, right? I use the example of computers. It's the same thing with mobile phones, right? So initially, they will be adopted by agencies where performance is the key, and they can afford to pay that extra amount, right? So a lot of quantum, if we talk about quantum technologies, right, a lot of quantum communications related uh, early adopters in that case are banking institutes, financial institutes, government and defense institutes, because they can afford to pay that markup, but the KPI and the improvement in the metric is a must for them, right? Quantum computing, for example, a lot of pharmaceutical companies for sequencing and so on, I think they will be the first to adopt it, because again, they can pay the markup if you guarantee the quality and the advantages of it. Uh, we have seen it in several other industries. I think history is something we can all learn from in several different aspects. And gradually, then, I think over time, again, with the NRE distribution, with the economy of scales coming in, it will become more and more mainstream. Other industry will adopt it. And consumer electronics generally is the last one, because consumer electronics is very much price driven, right? You have to keep the cost really, really low. So I would say it's one of the last phases of implementation of these things when it comes into play.
Okay. Well, during your research days and your work in Europe, so you have worked in institution, not only ASML, also like imec and VTT Technical Research Center of Finland. So what kind of research you are doing, if not disclosing any
Sure.
confidential data? And also let us know how it feels, the research environment, the environment of the institutions, uh, your experience, hands-on experience working there in
Right.
Europe, what it
Right.
feels like.
So in VTT, I was primarily looking into 2D materials, graphene, some transition metal dichalcogenides, so TMDs as well, looking into detectors made of them, high efficiency phase shifters or modulators with the same. imec, I was more looking into sensors with a little bit of work more on the what is known as DC curve based modulators, which is don't want to get too technical on it, but just to explain it, so an issue that we face with silicon-based modulators, which are primarily consisting of an interferometric structure with phase shifters, is that there's a change. As you ideally just want to change the phase in the phase shifter, you, as a consequence of it, see a change in the amplitude as well, which is undesired. So this was a means to kind of overcome it and look towards more pure phase shift, as opposed to and reducing any kind of residual amplitude modulation, as it called, which is the change in amplitude as you're just trying to change the phase. In terms of environments, I think if again, it was a wonderful experience, a testament to my good luck, I would say. I think some brilliant researchers working there uh, had the good fortune of let's say learning about a few other fields as well. There was my colleague. I think she is now in, I forget in which university, but in one of the universities in Finland as a professor. She was working on Shaini Mojumdar. She was working on hafnia zirconia based neuromorphic based materials for neuromorphic computing. A wonderful and brilliant lady. Got to know a lot about basically memristors from her, although that wasn't uh, my specialty or what I was working in. But vicariously and in discussions, you get to learn a lot of these things. Same thing in imec, for example. Even before working there, I'd been fortunate enough to have some working relationship with them, doing some fabrication there, some European projects, and so on. But being in there and looking at the technology and the immense development which is ongoing, right? That, if not anything else, is very motivational. And one key takeaway from all of these organizations that I have had is an emphasis on self-learning. I think that is very understated. And self-learning doesn't, maybe as the name implies, doesn't just mean that you are left on an island by yourself. Self-learning, at least to me, means that the core or the majority of the effort comes from you, right? To learn something, to understand something, or broaden your horizons. You always have colleagues you can talk to, people are friendly, engage in conversations, right? But it should not be what oftentimes, or at least in my childhood, I think we were more used to, where you have, for sure, metaphorical, sometimes literal hand holding as well, and every line of an equation is being deduced and you're just noting it down, right? I think that's the core of it, where the effort and the drive should come from you, and then you have a brilliant team, approachable and friendly people who you can always talk to about problems, right? And an answer to it can also be, just look at that book and you will find a solution, right? So then the onus is on you to read it up, to go through it and find all related items. So that's what I would say about it.
I have, as much as an outsider, as much I understand that in Europe, the research culture, obviously, in fact, I have done a little bit of research after master degree, 3 years. So that time I have seen that, because I used to read papers that time because of the work also, obviously. So fundamental research regarding that thing, Europe is very strong in that area, isn't it? Very strong. Their culture is really, research culture is really very, uh, I would say, completely different from India. At least
Yeah.
at university level, what we get, that's completely different. And have you seen any kind of like multi-institute project? A big project is going on, multi universities are taking part there. This kind of project runs there?
Loads. And it's not only multi-institute. I've been fortunate enough to um, work on, at times lead, at times apply for myself, several such projects. But oftentimes it also includes some commercial partners. And the commercial partner can be a big MNC, can be a smaller entity like a startup. Uh, so the environment, I find it, and you can of course call me biased, because it is fair to say that I started my professional career in Europe, but I do like the way of working and the thought process in that regard, especially what is prevalent in Scandinavia, Western European countries, and so on, right? There's an emphasis on efficiency. I don't want to digress the conversation too much, but I do like, I think a lot of people dislike the entire commentary which was made about what we need to work 70 hours a week and so on, right? I think that's a service related mentality rather than something which is more creative. Oftentimes, and I've discussed it with other Indians as well. I think the general consensus we get about Europe quite often is that they work 9 to 5. After that, they do not work, and the implication or the underhanded implication is that they are lazy or something. That is absolutely not the case. They are very efficient. You will not find during working hours anyone being on social media and spending their time. When they work, right? And I think that warrants a lot of merit. That is based on efficiency, and the outlook is very much IP driven. Again, I might be biased because professionally that's where I started off my career, but it works very, very well for me, and I see the merits of it. You have government proposals and projects whereby it is not only encouraged but mandatory kind of to have multiple entities present. Entities can be academic, can be research institutes, again can be companies, and I think it gives you best of all worlds. It gives a lot of focus to the work that you're doing, right, with a particular end goal. See, commercialization, sometimes you might succeed or not succeed because of a lot of different reasons, right? It might not be related to technology. It might just be related to uh, I don't know, the cost of it and a lot of other items, right? But I think a goal of having a tangible output, especially in large scale projects of this sort, I think merits a lot of or warrants a lot of merit, right?
Yes, there is a difference in the culture. In fact, I would say I as a platform, we know someone. Uh,
Mm.
he is not connected to any university or not directly like researcher or kind of. He conduct a lot of uh, workshops, publish tutorials. He is so he is in PCB making. He is one of
Right.
our guests in TSP in early days, very first few episodes, and he is so disciplined in his work. Every 15 days, I find that he is having a live event, and I have attended. I don't understand anything, but the interface he is showing where he is designing the PCB, it's so intriguing the way he is explaining. And obviously with his Eastern European, I think Eastern European accent in English, he's self-disciplined. He is a kind of a what should I say, self-employed person, but the kind of discipline, with discipline he is working there, and it's very strict. Not that I am a self-employed person, so I will spend not 70 hours, 90 hours. I don't. No,
Right.
he is so strict and so, I mean, well defined, well balanced routine. As much we can see from this side, that makes, yes, at personal level also they are very much in, they actually they grow up in that environment, so that imbibed in their very character.
Absolutely.
Yes.
Absolutely. And I think it's a bit of a misunderstanding as well. You have to see people closely to understand it. Like with the 9 to 5 thing, and I've heard a lot of Indians complain about it, so to speak. It's not like people still are not thinking about work, right? And of course, in every populace, you have a distribution of people, right? Not everyone is the same. People are not homogenous. But even after that, next morning, I would find my colleagues come and say, I was at home, I was thinking about it, and so on. So they're still thinking. It's just, I like this way of working because I think it gives you a clear time of what is your time and what is work time. That gives you mentally the opportunity to recover. And if you so choose, you can also still continue thinking about work because, when you love what you do, it stays in your mind, right? It just doesn't go away. But it gives you the liberty, I think, and that's a very, uh, well, no pun intended, a liberating feeling and a liberating environment to be in. And also that creates a lot of accountability, which I do value a lot.
Mm. So you have witnessed the photonic ecosystem and community in Europe. So how it's different from rest of the world, and what you are right now, you are working in India, so the ecosystem, and or should we
Well,
skip the question?
no, I'm fine with it. I don't mind discussing it at all. I think it's fair to say um, that it is in Europe. It is one of the best ecosystems in terms of photonics across the globe itself. I won't go into the debate of what is the best or not. I'll leave other people to participate in that. Uh, but in terms of initiatives which were taken from early days to right now, I think there's a lot of things that deserve, or at least where Europe deserves a lot of credit for building things, or at least in terms of ideas, pilot line projects, even to test out things, starting from fabs to development and so on, right? Uh, how are things different in India? I think it's quite a bit. I think no one will mind me saying this, that we are still work in progress. Often I have the, which is again not meant as a negative, that's just the reality of things. I have often the debate with a lot of colleagues and a lot of other people as well. Again, I am biased to certain ways in which things are done in Europe, but India is definitely not a homogeneous mass. We all have our own opinions, and usually our opinions differ quite a lot. So I don't know what will be our way to success. In terms of what I do prefer, I do see certain things missing, and hopefully they develop over time. But there's a thought which certain people share with me, which I can never negate, is that maybe we will do it our own way, whatever that way is, right? Maybe it will not be that strict way of working, or very um, very much like a guideline, or the process that is followed in Europe. Maybe it will be our own way. That is yet to be seen. I will never negate that. I'm not the kind of a person who thinks that the world revolves around me. It doesn't. So maybe we will find our own way. But I think at least there are improvements happening in terms of the commercials. We are still doing our fabs and packaging and things of that sort in other countries. One thing I would advise, or would like to see at least in general, is firstly understanding of what IP is, because in India, I think most of the times when I have conversations about IP, people just think patents. That's not true, right? There are company secrets which you can classify as know-how, which hold equal merit in terms of IP and its utilization. And also, there should be some stress given to utilization of things rather than just, let's say, on paper development. So I do find that sometimes we, as a country, a community, and a group of people in that sense, are guilty of thinking that, okay, let's get some patents done, right? I haven't looked at the latest numbers, but the last time I looked at the numbers a few years back, you look at the utilization of a patent in Europe, or the average numbers for it, and the same in India, right? It's a lot lower over here, right? And I believe that everything that we do in life has a purpose to it, right? So when you're patenting something, it's primarily alluding to commercials. Doesn't matter if you're doing it as a university, as a research entity, as a startup, as an MNC, whatever, right? So I think those are the kind of metrics we should have more concentrated efforts on, and also maybe increase, or at least just a personal opinion, increase a bit more accountability in ourselves, and also a little bit of give people we work with, our colleagues or otherwise, a bit more independence, because that's also something I find lacks in a lot of work cultures that at least I have seen in India. Creativity demands a bit of independence. Of course, it doesn't mean that you just give someone independence and don't look at what they do, right? Let's not take things to the extreme, but a certain amount of independence without having a lot of micromanagement in there, I think, is demanded, right? Otherwise, how can you be creative and think for yourself, right?
Agree completely. Though I have not spent that much time, but I have spent 3 years in research and 6 years in industry. So, and because I had to take 2.5 years of break because of my daughter. So
Right.
at that time, the other person in my family, he was working. So I was getting the news every day. It was so while packing the lunch and cooking the dinner, I was always get to know what is happening in office. So yes, that another thing I would say, we have worked. We had really, with respect to the kind of life we had before joining any job, or we are from very mediocre background. So we used to get very high salary, a lot of money that way, but couldn't enjoy a bit because no, the leave very much limited. In fact, after my daughter, it seems like so many work without pay, where every month we used to have, because because we had to take because I think it's too strict. The industry condition, you say, and micromanagement, and not that liberal. The ambience is not that liberal. Whatever we say in convention or conferences or even on Women's Day, but the truth is that women are more critical about women. That is the scenario of the industry in India. I cannot say about the other country, but have worked here. That is the thing. So when in one of my company, two of my colleagues helped me, really stood by me. I always try to mention their name because I always find their angel for me. That time they helped me. Right. Helped women. That's a rare thing. So yes, and my next question was actually, how does research culture in Europe compare with India? I think you have already covered both research culture and the ambience of corporate.
I will add something to it, and hopefully most people that I've worked with in India after coming back will attest to it as well, or at least that's my wish, so to speak. That's what I try to create. I think also having a very strict hierarchy is something I'm not a big fan of. I don't think it's very positive. It's very productive. I personally, and again, I'm sure several people will disagree with it, I dislike the whole fact that if you're reporting to someone, the intuition that we have because of society and everything is to refer to them as sir. I always tell people, see, unfortunately, I don't have a knighthood, nor am I a bureaucrat. So there is no reason for you to call me sir. And I think my name is quite nice, testament to my parents, but so just call me by my main name. It's absolutely fine. Or in a very Bengali way, I would say, if you feel uncomfortable with it, just call me da at the end, right? I'm fine with that, right? I think that's something I would hopefully live to see the day when that is no longer prevalent, because I think that causes a lot of a very strict hierarchy where people are even afraid to speak up. I don't find that constructive at all, right? In fact, it works the other way around.
Even if you speak, it's really not accepted. It's not well accepted.
It's not accepted, and it's also again, this is my
even critical. If you are a woman, even critical.
Right.
Be judged at every step. I face that, so I understand. One more thing, as a Bengali, you have another advantage, you and me, because we have some sweet and terrible nickname. So if anyone,
yeah, that's true.
You can call with that name. So so we have very nice. We get nicknames.
I would rather keep my nickname hidden, but that's neither here nor there for other reasons altogether. But yeah, I do, and I think that's one of the reasons why, in terms of accountability, right? I feel it reduces accountability as well, and it reduces people from making decisions, right? Especially with people, this is something I try to convey. A lot of people I've worked to, a lot of people that I worked with in India, is that there's a reason that we are working with, or we have hired someone who has a doctorate degree, right? It's not just because you have a fancy degree and you can write a title called doctor at the beginning of your name. That means nothing to me, right? It's basically with the understanding that you bring about a lot more, let's say, intellectual component to the work that you do, rather than making it more laborious, right? And you have that freedom of thought, which also I need to encourage, right? That you bring that about, and I give you the space to express yourself freely, and you will make mistakes. We all make mistakes. Even I make mistakes now, everyone, and I will continue to make mistakes. It's just a learning from that and moving on in life. I guess that's what we do in general, right?
Yes. Okay, now let's talk about your startup journey. You has co-founded a company named iPronics Programmable Photonics. What actually, you have done in that journey? What kind of work you have done? Just generalized information.
Sure. So it was, I think, I won't rank things in my life, but maybe one of the most happiest coincidences which happened in my life. Never planned for it. If you ask me till 2017, 18, whenever we started with it, it was completely unplanned for. Definitely from my side, right? So we reached some IP potentially, the first IP related to what you can, to keep it simple, coin as a photonic FPGA, right? So it's the same concept. It's a hardware set which can be programmed to perform multiple functionalities, right? Similar to FPGA and electronics. Uh, we we came across it. We made some patents to safeguard it. Then the realization was, okay, can we do something more? With Except for Jose, I think none of us had experience on that front. So we were like, okay, let's look at possible funds for it. We got it through, at that time, European Research Council had a POC, proof of concept fund, applied for it, a lump sum amount, we got it. And that covered initially a lot of the legal expenses and other related items for us, and we went on with the journey. Knowing very little about the terminology involved, the business side of things, and so on. Being more on the technological front, that's what we knew. So even things like, I remember, and I mentioned this to people, like, and have a laugh about it as well. Even things like CAGR, CAPEX, and so on, we were not really well familiar with it. We were reading up extensively every day, every weekend to figure out, okay, what are even the basic business terminologies? How do we plan for them? I remember a conversation where early days, I think we hadn't even registered the entity, and someone had asked me about exit strategy. And I was like, what is exit strategy? Is it like the exit gate marked over there? What are you asking about, right? So it was really learning by making mistakes to a certain extent. And I'm talking about myself because Jose had some experience on that front, and maybe some of my other colleagues as well. But it was a lot of fun. And while doing it, you realize some of the nuances involved, and something which in my life I never thought I would enjoy, I started enjoying it because there were so many different perspectives involved, and every discussion was multifaceted because it was not only on a technology front, it was technology combined with the business, combined with the commercials, combined with even things like demand and the need for it for people, right? I think that brought about something, or that got a lot of interest built up internally for me to do these kind of things. And other than calling it just a photonic FPGA, one thing I would like to mention, something I think with if for people in the audience who have some experience in optics and photonics will be really able to relate to, is we were automating a lot of this programming of the hardware to perform different functionalities, which in turn also affects some core problems of photonics. For example, these kind of fabrication related errors or issues that we see in the circuits that I mentioned to you, right? These phase errors, what we call them. You can also tackle those by automating. So you build a large scale circuit. On paper, it works fine. In reality, you do it and you see every device is working a different way, right? So you can do an initial calibration in an automated means, which is effectively the crux of what you need to make things more commercial, right? So there were a lot of large scale implications, I would say, on the work that we are doing and that we were doing in iPronics. So definitely a wonderful memory and a fond time spent in Spain.
You know, risk taking, and actually when you start anything, you really don't know. I mean, how is it possible calculating all the risk and knowing everything? Because if you know everything, then that thrill somewhere go missing. And yes, actually, many people asked us, we have not done anything big, but every step, if you start at point, what next? If you ask yourself, something reveals, some path open ups, and kind of many people ask us how you planned, and nothing. I don't really think we can plan anything. If you try to do something new, it's not always planned. It doesn't happen in that way. Some things shape up in nature. I think that is the universal law of something shape up in its own way. You don't know, something
Right.
will work something will not.
Absolutely.
But the journey is, it's sometimes very much tough and very much frictionless, and you always get a lot of heartache there also. Still you continue the journey because somewhere you have the conviction that you are doing it right. Yes.
Absolutely.
Actually, recently I was listening to someone, a very famous one, Mr. Sanjeev Sanyal. Probably you know, the economic advisor. He was saying in
Yep.
Bengal, we need to bring back the risk-taking entrepreneurship. That should be encouraged. Because I was listening to one of his interviews. What you people did, you took absolute risk, not thinking, and then figured it out. And but the way, has anyone discouraged you with this journey and that experience? Anyone? Because if common people, I mean, those who don't believe in your conviction, there is a tendency of many people to discourage you or channel you in some other way.
I don't think so, at least not that I can recall. I think definitely not saying this for the sake of it. A very supportive family helps out. But I think a big part of it might also be my personal mentality and nature. There are few people I would say who I really consider as mentors, but really fortunate enough to have like really, really amazing people of that ilk in my life. They have always been amazingly supportive, and the rest of it I have never really paid heed to it. Maybe that just helps me in this journey. But yeah, that's how it has been.
Good. That habit should be. I mean, otherwise, uh, one should have this kind of habit. Otherwise, you cannot do it.
I would also like to say I think that's one of the biggest learnings in research is not being afraid of failure, right? I do mean this. Maybe the numbers are a little bit exaggerated, but the average day of research, I think, is more failure than success, right? I mean, the immense, and this is not only for me, for everyone else involved in it as well, right? The immense number of days where you're scratching your head in the lab, what is not working, why is the measurement not correct? Same thing when you're doing fabrication or anything else, right? I think it builds a kind of character which suits this. That's why I find actually it's research and startups, so to speak, have a lot of similarities in that sense.
By the way, when you are talking about that hierarchy and micromanagement, just a funny incident I recall. That time I was working in my first company, and obviously I have joined as a engineer, and I really not always regarded, I think. So a very kind of, what should I say? I cannot explain it. I mean, I have my opinion in everything. Okay, understand.
Right.
Opinionated, strong woman, you can say. So so I was about to, for 2-3 days, in release, we were doing some release for a product company. I was in a service company. So from office to my house was almost 25 kilometers. So it will take time traveling in Kolkata. So I was about to ask for 3 days I was listening that today the release will happen. So I have to stay till 7:30. On fourth day, I was quite fed up, and I just sent one message to the, just mail to the, that time smartphone was not there, only QWERTY keypad phone was there. So I just sent a mail just asking the client side from manager or the teammate that are we going to have the release today? Because I have something to do at home. A very urgent thing was there. So when my lead came to know, he said, in my previous days, early days, I always used to shadow my senior. How dare you to send a mail? That kind of micromanagement. Still, now that time I was angry. That day I was very offended and angry. Now I almost forgot now. While I'm telling you, I'm feeling it's amused. How can a person just sending a mail? How can restrict someone on sending an email? This kind
Right.
of thing was there. Yes, I have faced that. So that micromanagement, yes. And let me tell you, just because I do podcast, I connect with many senior leaders. If I would have been a part of a corporate company, I hardly dare to go up to them and talk. But while I am talking, they are very helpful, very engaging, very warm. Everyone, each of them. Many senior leaders said, okay, right now I have many engagement. I cannot do it in coming few months. We can do it later. I said, yes, sir. Just when you get think you have time, please let me know. We can arrange time according to your availability. They are warm, they are not like that, but
Yeah.
inside organization the system is so strict and so not at all breathable. I would say, I mean, it's not you have to be always like that, very strict, very this way. That is not the scenario. These people are not like that. They talk, they are warm. They while if you crack a joke, they will smile. If any funny
Right.
incident, they will smile. In fact, they share their many funny incidents of from their life story. So
Mm.
I understand that is the culture, nothing, not the person. It's not that thing.
Yeah.
The way it has been for last 20, 30 years, the way it, no one dare to change it, so it's not changing. Okay,
Yeah. Yeah.
let,
Absolutely.
let's get back to the question. The next question is that what are the biggest challenges in building a deep tech photonic startup?
Interesting question. Well, I'm debating now. Should I start with talking about technology? That's what we have done before, or should we talk about maybe the other aspects, business and related aspects? Do you mean from an Indian perspective or global itself?
Mm, first, you say global, and where we
Okay.
lag in India, that will be better to understand.
Yeah. I mean, I'll start maybe with a non-technical perspective as well. Uh, One thing I would definitely say, and I will maybe add a little bit to it. I'll not only talk about deep tech photonics, but more on the hardware side. That's primarily what I've done in my life, because software might be a little bit different. Um, so funds are always required. That's, that's the reality of life. Without funds, we cannot do anything. I have always been a believer that when you're talking about funds, when you're planning for it, doing your financial plan and related items, right? Do not just think about that. I need to raise X amount of money. There's a validation and a process that you need to justify people who are investing their money, right? So put yourself in their shoes, but also think about what do you need to kind of achieve to raise money at the right valuation for yourself, right? I think it's a very uh, tricky thing in general, where you should never undervalue yourself and you should also not overvalue yourself, right? So those kind of nuances, I think sometimes you just have to learn it from experience, but otherwise you might have it internally as well. I think are very important in a build of this sort. uh, in terms of a deep tech photonics startup, um, I would say in certain instances we are guilty ourselves of overselling. I would advise a word of caution to it. Um, Again, everyone has the right to have their own opinion. This is just my own. I think as a community, it serves us better if we avoid certain instances of an oversell. Uh, I think it is also very pertinent, very relevant, and important if we look at tangible goals while doing any kind of a build, be it a product build, be it a startup build in its entirety, right? Because sometimes I am quite crude when I think about things, and I oftentimes end up saying that words are at the end of the day vibrations in the air. So they can or often do mean very little. But if you have something tangible, which doesn't have to be perfect, right? But if you have something tangible with works, which suffices, let's say, out of 20, what we classify as KPI, key performance, right, related indicators. So metrics whereby you can demonstrate a performance, right? Out of 20, if you're meeting 10, right, that holds value. It's not like it's valueless. It shows a promise that you have a certain level of development, so people can have faith in you. It can show progress, and then what you do with the other 10 is you show a plan and put a lot of thought into how can I improve those other 10, and while preserving the first 10 which I've already met, how can I reach the other 10 as well and improve on those, right? I think that is what people are generally looking at in terms of, let's say, investors, or that's generally what is a very nice way to plan things and build things as well, again, in my opinion. Uh, Other than that, the big challenges were currently, and I don't mean to get political when I say this, but the reality is the geopolitics is something you have to consider. Not only talking about tariffs, but uh, I can barely think of any country which can do the entire chain from harvesting the material to growing it to a full packaged integrated kind of a system, right? So you have to do some things in some other places. Please do bear that in mind. Import export, these are very realistic thing. Import export regulations and even getting things subcontracted in other places has I mean, it has a lot of large scale implications in terms of the business that you're developing. Uh, what else would I suggest? A personal favorite of mine, an adage which I do love, is devil is in the details. We definitely cannot plan for anything and everything. Murphy's law is mostly true. Whatever can go wrong does go wrong. But I think thinking things through and having a detailed plan as much as possible is very important. Always prioritize quality is another that I would also say. And yeah, exercise a bit of flexibility when required while again preserving the quality. I think these are the main things that I can think of.
Okay, so now I will ask some question on quantum computing also, because these things are very closely related. So as much I was doing preparing for this podcast and reading a little bit, I need to read a little bit, just not talking. Somewhat, some people tag me as a journalist. I'm not. So why is quantum computing considered a threat to current cryptographic systems?
So I think this is a statement again made by a lot of people. I will change the statement a little bit and I will say it's not only quantum computing, it is significant advances in any kind of computation. That can also be advances in computing through other accelerators, which are not really quantum computing. So what we are doing in cryptography, basically, we are safeguarding the information using very complex mathematical means, right? You can think of it this way as Moon being very being amazing at maths, can encode some information in complex mathematics, and me being inferior in that sense, I cannot decode that mathematics. So that information is always safe from me, right? Because I cannot decode it. Now, if I have, by some means, by hook or by crook, increase the capability of analysis of mathematics at my end, right? I can then decode that information and steal the whatever, be it secrets or otherwise, that is basically in a cryptographic means stored in that kind of information, right? So it's not only quantum computing. I would also argue that any advances or any major advancement in computation, which will help you decode these very complex mathematics, working with very large prime numbers and so on, which are about the basis of cryptographic systems, does act as a threat to any kind of a communication system, especially a cryptographic communication system. Now, again, of course, the geopolitics and the current state of affairs in that sense makes this of relevance. On top of that, of course, there are a lot of let's say a lot of agents which are trying to steal information, be it for us, the Aadhaar number for Americans, what is the word that I'm looking for? Social security number, your OTP, things of that sort, right? So there are spurious reagents, even leaving aside the geopolitics, where this becomes important. And the protection of that is basically what we are looking at. What is also important to keep it in mind, because people can argue, and it's a fair argument, that a true quantum computer or that kind of advancements in information, or not information, computation and processing in general hasn't happened yet. That is true. But if you start thinking of a problem when the problem actually becomes an issue, I think you're already too late, right? So you have to kind of think in advance about it. And that's where the world is right now. It will be a considerable amount of adaptation that we have to do in order to safeguard ourselves, including building new products. That's where the world is. That's what we are doing at amPICQ as well. And yeah, that's where it is.
Yes, and my next question is also regarding that in amPICQ, you people are developing photonic integrated circuits for quantum communication. So how these chips enable technologies like quantum key distribution? That is a kind of a security measure, I would say, isn't it? As much I have understood. Yes.
Absolutely, you're correct. It's
detail, just if you please say something about your work.
Sure. So this is basically, instead of being primarily more software-driven cryptography approach, it's hardware-driven, right? You're working with, so to speak, quantum states where you're embedding the information in it, and that effectively, if someone is trying to steal it because of the nature of the particle, the receiver will get to know that there's a third spurious agent who is trying to steal that bit of information, so it will be flagged as a red flag, right, in it. What we are trying to do at amPICQ is basically work on photonic integrated circuits and make products based on that which enable quantum key distribution. There are a lot of parallels between this and, for example, what we have seen in data center related application of photonics, right? The way the field kind of worked out was initially people were using discrete elements, so very large discrete sections put into a box, a very large one in itself, to demonstrate initial concepts and the idea behind it, right? That has been done in QKD already. Now moving towards more of a commercial adoption and a large-scale adoption of the idea and the process behind it. That's what has driven us to use basically photonic integrated circuits, because that's the expertise that we bring in as a team. We have, I think at this point of time, we are around 10 people, with the technical team being full of people with expertise in photonics and photonic integrated circuits. Most of them, not most, actually all of them with PhDs in PICS or photonics at least. And the goal is to develop this kind of a fully integrated product, which of course will be SWaP-C-wise a lot better. SWaP-C meaning size, weight, power, performance, cost. But also that enables the adoption of this on a large scale basis, because if I ask you to firstly change hardware today, that in itself is a decent amount of cost. But when I'm talking about changing hardware, and then I'm telling you that it's going to be very large, you're going to need a lot of space, a lot of energy will be consumed by it. That keeps on adding to the entire cost itself. And infrastructure cost, or changes in infrastructure, right, and the cost driven by it is never easy to manage. So the more compact you make it and the less of a toll it takes on the current existing infrastructure, it becomes better. So we are trying to make it compatible with, let's say, current and existing telecom systems, so that we don't have to change the wavelength that we work with. We can work with existing fiber optics and so on.
Okay, understood. So you people are working closely with quantum technologies. So since you are working in this making of buildings photonic chips, so what are the biggest engineering and manufacturing challenges in building scalable photonic chips?
Oh, okay. That's an interesting
Other
question.
than
I think
fund.
some things I've
Fund is one thing,
yes.
obviously.
Oh, fund is always a thing. So fund is, I think, I always joke and I say, if any discussion about a startup you don't bring up funds, then the startup gods get angry. You have to talk about funds. That is always there. I think a few things such as the phase errors, fabrication related sensitivity, and so on, I've already talked about. I'll maybe talk about a few other related items. The good thing about any niche technology is that it has a lot of opportunities. Maybe there are a million negatives for it, but the positive of really doing as the apologies for repeating the term niche technology is that it, so to speak, does not exist, creates a lot of opportunity and scope for you to develop, right? But one of the issues that comes with it as well, especially on the hardware front, is you need new tooling. Sometimes you need new processing. And so for all of these items, you will usually not have standardization. Now, standardization has a lot of benefits, but one of the key benefits of standardization is it reduces the cost and makes things available to everyone. So, for example, we have a lack of standardization in packaging, mostly speaking, in photonics and optics. Again, that's a huge thing to plan for because moving from one run to the second to the third, that means there's a huge delta in terms of how much you would spend, right? So I think this lack of standardization in general becomes very critical. I think Bureau of Standards, I'm involved in some discussions with them. They are trying to standardize a lot of related items, especially for quantum technologies and quantum enabling technologies. I think it's a very good initiative. If I'm not mistaken, it just started. So it's a very good initiative. Hopefully, it yields some very promising discussions and conclusions and outcomes coming out of it as well. Uh, Other than that, again, the integration becomes a challenge. The yield becomes a challenge. Making things tolerant to whatever can be fabricated or the other uh, or the resolution within which current fabrication means work right now, right? That becomes a challenge in itself. If you want to look at it in terms of the positives, it's that the science of it, or a big part of the science of it, I would say, in terms of photonics in general, has been done. It's more of scientists combining with a lot of engineers or moving towards an engineering role, right? That's where the commercial, the viability, making things just not work in a lab for 1 hour, but work in an actual temperature varying ambient condition for a year or 2 years, right? Those are the kind of challenges that we are looking at right now in terms of the development.
Okay. Uh, we have already talked about cybersecurity. What else could photonic chips have major impact? AI infrastructure, data centers, or quantum network? Major
Uh,
impact.
I would start off with one which is close to my heart because I've done some European projects on it, which would be AI, especially hardware accelerators, which will have a very major role to play in terms of uh, the adoption, usability, and the capabilities of AI going forward. Another one, which is I think more of a general consensus as well, is sensing. Also in quantum sensing, I think photonics has a lot of role in that, and quantum sensing, I think, in terms of again the general discussion and agreement that people have in the community, in terms of a commercial release would be one of the first things that we see in this globe, or that's the expectation related to it. So these two for sure. I think data centers are already being impacted by photonics. It's just the nature of the impact will keep on increasing. Quantum networks as well. Also, since I mentioned AI at the beginning and something I alluded to earlier, I think in terms of edge computing, I think photonics has a very large role to play in it. So these are the primary ones I can think
Okay. We are almost at the end. It's a long conversation.
of. Yeah.
I would obviously, since it's going on with full, it's propelling in high speed. So I would ask about that with initiatives like India Semiconductor Mission, what opportunities exist for photonics and quantum communication in India?
Well, opportunities exist in I mean, the existence of opportunity is quite large, right? Uh, in terms of a market, we are a very big market. Telecoms in general, if you talk about it, is a very big market in India. I forget where the exact global ranking is, but it's definitely at one of the top kind of levels, right? Uh, Execution of it, again, I think we kind of alluded to it earlier. I think we are working towards things, a lot of things, which are, it's too early to tell how good they are going to work or otherwise. So I think we have to wait and see a little bit. Uh, Definitely a big promise with Indian Semiconductor Mission, with the fab coming in. I think PMC and PowerChip and Tata combined, a few other packaging entities as well. There's also supposed to be ISM 2.0, National Quantum Mission, where we have some involvement in that part in terms of the funding. What I would, at least in terms of a few things which I think will enhance the prospects of coming across from these things, I would definitely concentrate on improving industrial or at least startup and academic collaborations. I think that if there's some added notes added, some added notes in there in these kind of different missions that we have, even the AI mission as well, I think, which is just about to take place. I think that will go a long way. I think a commercial drive for it, and do not get me wrong, I am not saying that everything should have a commercial drive. I think basic scientific research, theoretical research, that holds merit as well, right? So I think there should be like different structures for it, similar again to what is being done in Europe in several aspects, right? You have pure theoretical research-based grants and opportunities. You have academic lab-based work as well, and you have a combination of things coming across. So I think that, and also having tangible outputs to certain projects, keeping people a bit more accountable in terms of the outcomes. I think that holds that bit of accountability associated with projects, I think holds a lot of merit and value to it as well. And also maybe a very personal opinion, let's not get too swayed away by the fact that, okay, in a project we had 10 patents. If no one is going to license it throughout the lifetime of the patent, I do not believe it serves a purpose. So let's try to find a way where we can not just count on metrics blindly, but have an analysis of the metrics ourselves, right, to see what we are doing right and wrong.
Fundamental research is very important. In fact, I know few European countries, fundamental research is really good regarding compound materials and all. So although there is not much scope or of industrial usage and application, so those many teams, at least one or two teams, they want to collab with Indian universities. I know they want, because government is very much keen for energy materials and 3.5 materials, so to promote this kind of products, because as you said, if the market is big for telecom sector, it's big for automotive sector also. So because huge vast country with huge population, obviously. So it's when central government is looking for this thing. So I know, I mean, I'm also connected to few people, so I get to know all of these things. Yes. So fundamental research, look, just because their fundamental research is so good, they are getting associated with that. So in that area also we can improve, and we can learn from them, and we can implement that in our in-house research capability. If that get improved, that will actually in the long run help us. Absolutely. Yes, absolutely. I completely agree with you. And my final question about what skills should young engineers develop if they want to work in photonics and semiconductor deep tech? What is your opinion?
Yeah, it's an interesting one. I mean, the two in general, I think this is across industries for me, which I value a lot, um, is basically having accountability, having the skills to self learn, right? I think these go a long way in general. I would go as far as to say I believe that these are the two biggest learnings from my PhD, at least. One, I think maybe it's not talked about quite often, but the reality is whether you do hardware now, whether you're in a lab doing measurements all day, you're doing fabrication or whichever, right? We all need to code and we all do code. We might not be amazing at it. We might not code in the most efficient way, but we need to. And with more machine learning techniques and AI-based approaches coming, right? I think it's going to increase. So definitely have a look into that part of things, right? Uh, I think that holds a lot of merit in itself. Um, and in terms of learning, I do think that we need to concentrate quite a bit on what is scientific methodology and the understanding of it and the implementation of it. So I quite often find people, and this is unfortunately, I feel like to a certain extent this might grow with more adoption of ML and AI. Is okay, in Python there are several enabling factors, whereby you can use a learning approach or an AI approach or something, right? But if you just blindly put it in a function built by someone else, where you have no understanding of what is going on in the background, like with every function and process, it has its limitations, its boundary conditions, right? Uh, that becomes more of a risk rather than a reward, so to speak. So please, you don't have to be an expert in it, but at least a basic understanding of what is going on in terms of the background process, right? I think should be something which people concentrate on, and also understanding what it can and cannot do and why it can and cannot do. I often subscribe, I don't know if it's the best way or not, that for some basic means, at least just do the maths by hand, right? Using a very simple problem in a particular kind of approach that you're doing, be it regression or whatever more complicated approach that you are doing. Just do a simple example by hand. It's 2026. Let's not be lazy. There are immense amount of resources available online by some brilliant people and professors. We can always follow them, have at least some level of understanding, and then do the implementation, right? Other than that, I think drive and finding, let's say, without sounding too emotional in that respect, your love for what you're doing. I've always found it that has helped me in several difficult times, in times where you're like, okay, this is never going to work out, but you still find a way to go ahead with things, right?
Okay, so I had a lot of questions, and when I send you the questionnaire, you never said no to any question. So our discussion spanned for, I mean, 1 hour 30 minutes. So
Yeah.
if I have left anything and you want to raise that point or want to discuss anything in your mind, please share. I ask this question to
Well,
all of the guests. Anything I have
well,
missed?
a lot of things, primarily because I do love to talk, but so jokes apart. But one thing I do want to mention in general, I think you mentioned a lot of students to join in, or maybe young professionals, so to speak, is something I am trying to arrange with a colleague, an acquaintance of mine who is a lawyer as well. But I think people should keep that in mind. Is I feel like a lot of times in India, legality, what we see around us is assumed to be legality rather than having a look at what is the reality of it. And again, it's 2026, resources are available. So please, I've seen people undervalue themselves, sign contracts, to be honest, which are not, let's say, very legal. And I'm being kind when I say this, including including bonds and things of that nature, which are not really correct, right? So I'm trying to arrange with this lawyer, hopefully it happens within the next 6 months, a session whereby he talks about basic contractual law. But I think we should take the onus on ourselves as well. Again, it's not 1926, it's 2026. So don't ask ChatGPT for it, but you can at least look up a book, a basic book on Amazon, read it yourself, understand what rights you have or not, and otherwise talk to people. I mean, we have social media, right? We can talk to people who have experience in these matters. I think that's part uh, uh, of what young professionals need to be aware of. I've been fortunate enough to meet some very driven, very talented individuals, but they have had the misfortune of being in some very difficult situations, which has taken away a lot of their drive and a lot of things from them, which is a very sad scenario. So I hope that doesn't happen to anyone. And if I can help somehow in that regard, I try please feel free to reach out, LinkedIn or otherwise. And yeah, hopefully some of the things help in terms of at least accountability, freedom of thought and development. Again, I think we have some really wonderful and brilliant people who might have not had the right environment to progress. And if any of us, I'm sure Munun will agree to it as well, even if she has the opportunity to help you out, she will. And I think the same thing goes for me or most other people. So please feel free to get in touch.
Uh, me and Mridul, we started our career in 2010 with Bond. Okay.
Right.
So, in coming, let me tell you, nowadays, kids are, I would say kids, because they are really, so a fresh 22, 23 years old kid, he is much smarter, way smarter. We used to be in 2010. And what I believe in coming 25 years, this bond thing is not going to exist in Indian corporate system. I really think students are much aware now. It's not going to. That time, I mean, you understand that you are not getting good treatment from your manager. HR is not helping out that time. No one raised their voice. Recently, I watched one reel where the girl at airport is saying that I applied for leave 2 weeks back or 1 month back for I earned to travel, and my manager, while I am present with my friends in airport, he is calling me to saying that come back to your desk and solve this problem. Naukri jaye bhaad mein. She literally saying it on social media. This is the generation. So I really think that Indian corporate need to think twice or thrice in coming 25
I hope
years.
so. I mean, last year we had the right to disconnect law, which was passed, right? Again, I do not, by any stretch of the imagination, classify myself as a legal expert. I'm not. But fortunately or unfortunately, I have had to work with a lot of lawyers, and most of them have been quite brilliant as well. And I think even on the bond side, right?
Not even right, but the situation of people, their personal life, they even knowing that it's not right, they are not saying. The one fun thing, let me tell you, we sometimes post some polls because to anonymous polls. I really don't think the starting salary has much increased from 2010 or 2012 to this. And just look at the inflation. I don't know. Yesterday, I was just saying, yesterday or day before yesterday, I was saying, Mridul, that when we were in Bangalore, we were eating vegetables. Are they eating something or they just drinking water only? It's such an expensive city. Bangalore is a horribly expensive city, So I don't know, but who are raising this? Don't know who will raise this question and when things will change. Anyway, we have got some comments also. One of your friend Prohanjan, he said hello. And he said also that, hello, Dr. Prometheus, Prohanjan here. Could you tell where you see the photonic industry in India in 10 years? Can it compete rest of the world?
Okay, that's a tricky question, Prohanjan. Can it compete? I think a large part of it is yet to be seen. I think, and I'm not saying it's all this way, but historically we have been in terms of making things, right, on a global level. We have been more about buying things, putting them in a box, and selling it, right? And there's a very unfortunate incident in that AI, was it the AI summit or the discussion which happened related to this as well, right?
Yes, yes,
Uh,
yes.
does it mean that things are dark and they're not people who are trying to change it? Absolutely not. People are trying to change it, and I know some people who are working on truly developing things by themselves, right? It's not going to happen overnight. I don't know if 10 years is even a fair time scale, right? You're talking about a deep tech hardware company. You're looking at potentially 7, 8 years at least to see the face of something which can potentially be a product. So a lot of it is yet to be seen. But yes, there are challenges because you do see in several environments as well that the kind of habit, so to speak, of buying things and putting it in a box and selling it does work in a commercial sense. So maybe reducing or removing the commercial incentive of going for those kind of options drives a lot of local build. Um, Hopefully so. I think we also talk a lot about maybe it's a digression about OEMs as opposed to ODMs. I think in India we will most probably, that's my feeling, start with more ODMs, which is the original design, rather than original equipment. Uh, that itself holds a lot of merit as well. So there's nothing against it, but hopefully that transition happens sooner rather than later. Yeah, we're optimistic with a hint of caution, and the rest time will tell, I guess. That's the best answer I can give you.
Okay. He got his answer and said, thanks. Hope you are doing well, Prometheus.
Sure.
Your friend, Ranjan. Okay.
Yes.
So 3 comments came from him, and one comment came from a question. मैम आप podcast हिंदी language में कर सकते हो? Gagan Kumar, I am a Bengali and Hindi. I really don't dare to do that actually.
मतलब प्रॉब्लम जो हो जाता है, बंगाली लोग जब अगर हिंदी में पॉडकास्ट करेंगे ना, तो हम लोग का एक दिमाग में एक चीज काम करता है कि वी बेसिकली स्पीक बांग्ला, वी चेंज द एक्सेंट, और हम लोग सोचते हैं वही हिंदी है।
हाँ, हम
तो
तो
हिंदी
ही
में
खाते
कोशिश
हैं
कर
ना,
सकते हैं, लेकिन आपको समझ में आएगा कि नहीं, वो अलग बात है। तो
वो
our
अलग
Hindi is always up for question.
Another thing you have to understand, Gagan, that India is a diverse country with so many languages. I interview a lot of senior leaders from South India, southern part of India. They understand Hindi. They watch Hindi movies, much contrary to the general concept that they hate Hindi. No, not like that. In Bangalore, I have seen a lot of South Indian people. They are talking in Hindi, but with accent. That will create a problem. Although for so many years, unfortunately, we had a colonial history. So English has been a part of our curriculum. We understand. So if you want to make it in an official way, I would request Gagan Kumar to please try to understand English, and I think there are some other ways to translate it. The thing, I think there is a way in Google also.
I
So
was thinking the same one. Maybe a nice use case for AI. You can use like an AI tool for live translations. I don't know.
please follow it.
Subtitles.
आप AI का यूज कर सकते हो just to understand what we are saying. हम लोग क्या बातचीत कर रहे हैं, and many of our guests जो बाहर से foreigner है, वो हिंदी में कैसे बात करेंगे? Okay, we have guests from outside India also. So we generally use the format and we generally use the language English. Okay. Okay, my tech team is saying that YouTube now have Hindi conversations per video, so you
Yeah.
can use that. Okay, and now what is your plan for helping this process? I think Pravanjan has got find a very good way to talk to you.
Yeah,
What
we
is
haven't talked in a while. Well, my plan is trying my best, I guess. That's the most I can say. Yeah, I think trying my best, having discussions with several different entities possibly working on it and the different missions as well. In terms of what concrete will come out of it or not, I always say till something is signed and or completed, you cannot really say if it will result in a positive conclusion. So a lot of it is hopeful and wishful thinking, but hopefully some of it at least becomes reality as well. But it's not only me. I know that there are other people working on it as well. We in our team have a lot of people who are also looking into this kind of things. So yeah, just hoping for the best while putting in a lot of effort to make it true. So let's see.
Thank you for your nice comment. Okay, we had such a long, when two Bengalis sit, they talk for hours. That the thing, you know. And viewers, Prometheus has joined us today from Kolkata itself. We are two part of the city, same city, two different part. So connected, and we have talked. We had a fruitful, engaging, insightful discussion for almost 2 hours. And thank you, Prometheus, for these explanations you have given and given us a picture of how things work in Europe. And I think we can adapt few things. There is nothing adapting good things, isn't it? We always can adapt if we can, obviously.
Again, you might call me biased, but I'm always up for it. So I think change is a part and parcel of life in any case, and adapting something which is good and successful, well,
Yes,
does logically make sense, right?
yes, obviously. Okay, so we are done for our today's session. Thank you very much, Prometheus, for coming to our show and giving us all the answer of all these questions. I'm a very curious mind with, I mean, I think I just my head runs on questions, a lot of questions. I keep on asking people. So this the role of host of a podcast suits me really well because I ask a lot of questions to people. And YouTube gave me that golden opportunity to ask leaders, tech leaders, these questions. Thank you for coming to our show, and viewers, thank you very much for staying up to this point with us. Don't forget to like, share, and subscribe the video, and don't forget to follow Tech Simplified TV and the TSP. Another question at this time has come. Like, good evening all. Just now live came into my feed. Love the discussion, although watching from last 20 minutes. You always have the recording in YouTube. We are just concluding. You start it from the beginning. Don't worry. It will be there. It's a digital archive for all tech lovers. Yeah, thank you for your lovely words. Good evening to you also, Prithviraj. Thank you. Well, we will conclude our session here. Thank you for staying up to this point, and bye for today.
Thank you. Bye-bye.